So what is circular queue? To understand the concept of circular queue, let us start with an example. When we create an object of a queue, initially front and rear both have value -1. As if the queue is empty, then front and rear both will not point to any index of the queue. So index starts from 0 index. So if we assign front and rear less than 0, that means the front and rear are not pointing to any index of the queue. So front and rear both here we assign -1. Next, if we enqueue value 9 in empty queue, what the front and rear both will point to index 0. Normally, to enqueue an element, we just increment the rear index. But if the queue is empty, then we increment both front and rear, and both will point to 0 location. So 9 will be there at index 0, and if we enqueue value 3 after that, after enqueuing 9, then we can apply the simple formula as rear is equal to rear plus 1 mod queue size. Here the formula is rear formula is changed. In simple queue, we were moving rear as rear plus 1 or rear plus plus, that was a post increment. But here in circular queue, we move the rear index by using a formula which is rear is equal to rear plus 1 mod queue size. Now in this example you can see that front is at index 0, front is at index 0, and rear is also at index 0, but to enqueue we will change the rear index only. So the formula is rear is equal to rear plus 1 mod queue size, and now the rear is at index 0, so 0 plus 1 mod 9, 0 plus 1 mod 9 is equal to 1. 0 index, now as the rear is at index 0. So rear plus 1 mod 9 is equal to 9. So our new value will be at index 1. Applying the same process, when we consider this one example, when front is at index 5 and rear it is at index 6. Now if we enqueue a new value, like we are enqueuing value 4, if we enqueue the value 4 and array is queue is not empty, then we will apply the formula rear is equal to rear plus 1 mod queue size. Now you can see that rear is at index 8 till now. The rear is at index 8. So 8 plus 1 is 9. 9 plus 9, 8 plus 1 is 9. 9 mod 9 is equal to 0. So 9 plus 9 is equal to 0. So new value will be there at index 0. So as we see that rear is at index 8, rear plus 1 is 9, 9 mod 9 is equal to 0. So our new rear will be at index 0. So new value will be entered at index 0. Now you can see that if this was the case in case of the simple queue, when we have rear at index size minus 1, then we get simple message as queue is full. Even we have these values, even we have these indexes, empty indexes. Even having these empty indexes, we get the message that the queue is full. To handle this situation, we have changed the formula as rear is equal to rear plus 1 mod queue size to make it circular, to use the empty spaces which are before the front index. If we have empty spaces ahead of front, then we will use these spaces by concept of circular queue. So by some circular queue, we are using simple formula, which is rear plus 1, rear is equal to rear plus 1 mod queue size. So again, if we nq value 0, so now the rear is at index 0. So 0 plus 1 mod 9 is equal to 1. So our new index will be, rear will be 1. So front is at index 5 and rear is at index 1. So moving to our next operation, which is to check whether the queue is full or not. Now we can see that as we know, the circular queue concept is to enter the values in circle. So there can be a case when the front is at index 0 and rear is at index size minus 1. So to check that whether the queue is full or not, we have two conditions. First one is the front is at 0 and rear is at size minus 1. And second one condition may be front is at index 5 and rear is at index 4. Or front is at index 7 and rear is at index 6. To handle both these conditions, we can apply a simple formula that if rear plus 1 mod queue size is equal to front, as we know that in both cases rear will follow the front. How rear will follow the front? Consider this scenario like if front is at 0 and rear is at index 8. Now to check whether the queue is full or not, we can check rear is at index 8. 8 plus 1 mod queue size is equal to front, as 8 plus 1 is 9. 9 mod 9 is equal to 0. So again, this will give us message that the queue is full in this case. The other case, which may be like we have a front at index 5 and rear is at index 4, like this one case. Now the front is at index 5 and rear is at index 4. Now if we want to NQ a value like it, and if we apply the to check whether the queue is full or not, we can apply this that rear is equal to rear plus 1 mod queue size. As we know, the rear is at index 4. 4 plus 1 mod 9 is equal to 5. 4 plus 1 mod 9 is equal to 5. So now 5 mod 9 is equal to 5. Our rear is at index 4 and front is at index 5. So by this formula we can check both cases, if our front is at 0 and rear is at index size minus 1, or the front is at rear is following front. Like if front is at index 6 or front is at index 2 and rear is at index 1, then again we can apply the same formula and our the message will be as the queue is full. How this is applicable? Consider this one. Like if this is front and this is rear, now you apply the formula. Rear plus 1, rear is at index 8, 8 plus 1 which is 9, 9 mod 9 is equal to 0. So rear plus 1 mod queue size is equal to front. So we find the front which is after the rear index, as we know that the values, we consider this as a circular order values. So it's easy to implement this as by using the formula, this one formula. Another way to implement this is to have multiple conditions. Like we can handle both cases. We can say that if the rear is at index size minus 1 and front is greater than 0, then we can to enqueue the process, to enqueue the new value. This process is to enqueue the new value. If rear is at index size minus 1 and front is greater than 0, then we know that there are some empty slots at start of the queue. So we can move the rear at index 0. But by applying this one formula, you do not need any process extra steps. You can apply this formula to handle all the cases. So for DQ, we will apply the same process, same formula, but now we will change the front rather than rear. So consider this one scenario when front is at index 5 and the rear is at index 8. When we will DQ call the DQ method, then we can apply the process formula as front is equal to front plus 1 mod queue size. As front is at index 5, so 5 plus 1 mod 9 is equal to 6. So our front will move to next index, which is 6. So it's easy to implement this process. Like consider this one example when there is only one value in the queue. Like if there was one value in queue, then while dequeuing that value, we change front and rear both to and move assign the value -1 to front and rear. Like in NQ case, if the queue is empty, then we change front and rear and move them front and rear both to 0 index. Same for DQ, if the front and rear are pointing to one index, same index, then that means there is only one value in the queue. So we change the front and rear and assign them value -1. So here we can see that front is equal to 8 and rear is equal to 8. So while dequeuing, if we check that if front is equal to rear, then front is equal to -1 and rear is equal to -1. So to implement this NQ method, we check that if front is full, then we simply give the message that the queue is full. So supporting method is full will be, as we discussed, if front is equal to, if rear plus 1 mod queue size is equal to front, then return true, else return false. Simple formula is, if rear plus 1 mod queue size is equal to front, then return true, then queue is full, else return false. So if is full, then message is queue is already full. Else, in else case, we know that there is space in the queue. So this process, this block will be in this block we will check that if the queue is empty, then front is equal to rear is equal to 0. We will move front and rear both to 0 index. And if queue is not empty, that means there are some values in the queue, then we move the rear as rear is equal to rear plus 1 mod queue size. Sorry, this is not front, this is rear. Rear is equal to rear plus 1 mod queue size. So queue of now in both cases we assign the value at rear index. So after if and else condition, we assign the value at rear index. So in DQ process, first of all we check whether the queue is empty or not. Same, if front is equal to -1 or rear is equal to -1, then queue is empty, else there are some values in the queue. So again here we check this as if queue is not empty, then that means there are some elements in the queue. So first of all we save the value in return value, and if rear is equal to, if front is equal to rear, then front is equal to rear is equal to -1. That means there is only one value in the queue. If there is only one value in the queue, we assign front and rear to -1, and queue becomes empty. Else front is equal to front plus 1 mod queue size. While dequeuing, while enqueuing, we change rear index, and to dequeue we change the front index. Formula is same, just we change front and rear accordingly. So front is equal to front plus 1 mod queue size, and then we return the value which we have saved earlier. So the supporting method is empty is if front is equal to -1, return true, else return false. And other method which is full returns the boolean value. If it checks if rear plus 1, if rear plus 1 mod queue size is equal to front, if rear plus 1 mod queue size is equal to front, then return true, else return false. So I hope you have now clear concepts of simple queue and circular queue. Hopefully we will discuss in class session, and after that we will move to next topic, which is priority queue and double-ended queue.